Okay, so for example 9, we're going to use substitution. Just think about how when we were taking the integral, oh, here it is. When we take the integral and the derivative of the bottom is on the top, we're able to rewrite it as this. That's essentially what we want to do. So I've written the bottom here, and if we take the derivative of the bottom, that's 2x plus 2. So right now it says x plus 4. So our goal is to get it to say 2x first, okay? So if we multiply the entire top by 2, that means we have to reverse it by dividing by 2, okay? You can't just randomly multiply the x by 2. You have to do the entire thing, right? So that's why I put it in parentheses. Alrighty? I distributed that 2 to both of them, so that's going to give us 2x, and then that's going to give us 8, right? I didn't write 8, I wrote 2 plus 6. That's because we want the top to say 2x plus 2. Does that make sense? So I just went ahead and split it up. Alrighty? So now, from here, I'm going to write it in 2 separate integrals, okay? So for the first one, we have a half integral, and then we have the 2x plus 2, and then all the stuff on the bottom. And then for the second one, we have the half, and then we have our 6, okay? So now we go back to college algebra with completing the squares. I think we did this in the last section, but essentially this purple box is what we want, okay? This is what we have on the bottom, okay? And we're gonna use completing the squares, and that way we have a formula that we can use from section, man, I don't know the sections anymore. I wanna say 7.2, but I could be wrong. Maybe 7.1, I don't know anymore. But anyway, oh, well, I have it written here, that whole chart on page 81. But anyway, so yeah, we have this right here on the bottom, and we need to get it in this form on the left hand side. So our a is 1, that's perfect. Our b is 2, which means our b over 2 is 1, and our b over 2 squared is 1. So if we want it to look like this plus b over 2 squared, right now it says plus 5, but b over 2 squared is actually 1. So we don't want it to say 5, we want it to say 1. So essentially we can say 1 plus 4. Makes sense? So now this right here is this left hand side, and we can rewrite it as the right hand side. So x plus and b over 2 is 1, and then we're squared, okay? And then this 4 is the same thing as 2 squared, right? So now, I wrote the first integral the same, and then I've just rewritten this bottom portion right here, okay? The reason why we didn't have to do anything weird with this one is because it's in that form that I was telling you guys about. We just bring this 1/2 down, it's just a scalar, and then because the top is the derivative of the bottom, we do natural log absolute of the bottom, okay? And then for the second term, we just bring our 3 down, and then we use our little chart on page 81, okay? I will just flash that up on the screen real quick. I think I had it, yeah, written on this one, on page 81, okay? So essentially our u here is, did I not write it? No, I didn't. Okay, so our u here is the x plus 1, and our a is the 2, which means du would just be 1. So there is a 1 on the top, so that works out. So we can rewrite this as 1 over a, which is 2, tangent inverse u over 2, which is the x plus 1 over 2, and then we do our plus c. All right, and then from there I just combine that, and then that would be our answer. Oh man, I tilted the video again, I'm sorry.